All right. I think we're recording. So here we are back again with
Oh no,
XCOM.
you forgot to screen share, screen share.
Oh no, I forgot to screen share. Well, that'll be included in the video. The fact that I forgot to screen share.
Oh, I can't
Here.
see anything. I'm blind.
Okay, so there's the screen share. Okay, cool. Now you get to see what
Thank
we're going to talk about. All right, sweet. All right. Yeah. So I got XCOM again, which
Hello.
is awesome. Yeah. Um, and so what we're gonna do this time is we talked previously about the Java portion of the code, which is an attempt to be kind of like a low level shim layer between like the system and then the game, which is written in Scala, which I'm not that great at functional programming, so this is a good learning tool for me. And but we're going to go over like the parts of this that represent like the game engine. So
This is gonna be interesting.
yeah,
Functional game engine.
well, it's still mostly object oriented the way I'm doing it. Like I just learned some stuff about what's it called? Tag final expression represent. Oh, there's some of this stuff that goes over my head so bad. It's like I need to take a class in functional programming, in order to understand like the psychology of functional programming, because I'm still treating Scala kind of as a object oriented language, which it is, but I'm not taking advantage of its functional capabilities and the degree, the extent to which it can deal with generics and mind-boggling ways that Java can't do, and just it's a completely different mindset. I tried to learn Haskell one time, and I'm hoping that some of that bleeds through, and just over time, I'm hoping that I'm going to pick up, maybe, especially if I can get feedback from other people. That I'll start learning
I
more
think
and
you're
more.
not alone in this
Yeah.
quest of, yeah.
So
It's gonna be interesting to see the like the process of the game engine now.
yeah, yeah. So well, okay. So one of the things you need in a game is a camera. Okay, and I've got a little bit of separation of concerns here. One of them is a representation of the camera where it is physically, and so what its position is and the geometry. So I have, like for instance, I have vectors that represent the up in the world, and with the world up, the camera up, what's right to the camera, and all of these things are necessary in order to calculate things like matrices that transform something in 3D space into something that can be rendered on the screen, which is actually 2D, right? So, so this tracks that geometry. So you can set the position, you can set the yaw, which is like the left to right rotation. You can set the pitch, which is the up and down rotation, like if you tilt your head up and down. And so this is like like when you move the mouse left and right, you change the yaw, and when you move the mouse up and down, you change the pitch. And so here this is like a method for taking the mouse position or the relative movement of the mouse and adjusting this relates mouse movement, which is a physical input event, to what we want to do with it, which is to control the camera. We have relative movement that can be specified by components or by a vector. And then, so I have this thing where I lazily recalculate stuff about the camera. So if the camera doesn't move, then there's this bunch of math that doesn't have to be redone every time you want to render the screen. So, you're going to be painting the screen at like 60 hertz, but you'll only actually do input at a much slower rate. So there's all this work that only has to be done when the camera moves or rotates. And so, if that information hasn't been modified, then I don't recalculate it. So when you'll notice that here I have, whenever you change the position or whatever, it marks itself as modified. Now, the main thing that I want to get out of that is this view matrix. so you have there's two matrices you got to deal with. There's a view matrix and a projection matrix. The projection matrix is something that is set on the game window, and it has to do with depth foreshortening. And then you have the view matrix, which is like your orientation within that space. And so now that has to be recalculated pretty much every time you want to use it, because there's this dynamic view center. Like, as I mentioned last time, to deal with the fact that floating point has low precision, but the world could be large enough that you can't fit whole numbered coordinates into floating point value, we want to use doubles for as much as we can. And in order to be able to convert that to float, we have to recenter the world. So we have this dynamic origin that we're dealing with. And so when this view center is passed in, we have to recalculate. And JOML, along with all the other matrix libraries, have this convenient lookat method that lets you tell it, here's the position of the camera and the direction that it's looking in, and what's up. So you need these vectors, like where the camera is, what's forward, and what's to the right. And so you can calculate those using an outer product, vector outer product. And then we have, motion, moving forward, moving backward. But this is in terms of distance, like absolute distance, how far in each direction you're moving. Okay. But then on top of that, we have a camera controller that controls the, that actually is what understands like the user input, understands how long, very importantly, how long it's been between each time that you've adjusted the camera position. So if you've got a velocity, you want to maintain a constant velocity, then the distance that you move is going to vary depending on how long it's been since you last updated the position. So the camera controller understands the user motion with respect to input controls and time. So we're receiving input events that indicate like this is mouse motion, so that controls rotation. There's key events. These key events actually pertain to like quitting the game. Like all I account for is escape and quit. But I also can ask the window here when I actually ask the input state, is a key pressed? So if are we moving forward? I actually am going and querying indirectly GLFW. So I allow GLFW to bleed through from the lower level because it's not like multi-versioned like OpenGL. There's just one GLFW. So I can just rely on its key codes. So for
is there multiple cameras by instance? Like
there could be.
There could be. Oh, so the engine is set up to handle multiple cameras.
Yeah. A camera is just, a camera controls a view, right? So there's a projection matrix, and the projection matrix, according to the window and the field of view that you supply, is deciding how three-dimensional coordinates that are, some distance from the viewer get mapped to two-dimensional space on the screen. Okay, so as you further away you get, the smaller it's going to appear, closer to the center, that kind of thing. It's called depth foreshortening. Okay, but on top of that, you also have a view matrix that controls like where you are in the world and which direction you're looking, and that's what this camera is controlling. And it's just an object. It's a class. You can create multiple camera objects. So, if I want to do something funky like a mirror, in simulated a mirror in the game, I could probably, modify this to allow me to render like the view of the mirror from the perspective of. It'd still be relative to the viewer, but I could calculate a new camera position through that's on the opposite side of the mirror, and I could render it to an off-screen surface and then turn that into a texture, like something like that. And I'd use the camera model for that. So, and here we have an input. So this is an input receiver. that we talked about last time. It's something that the window manages. Okay, so you say, here I am. I'm an input receiver. It gets plugged in at startup time. So I somewhere in here, I create the window, give it a field of view, create the camera, and I tell the window here, that camera controller is an input receiver. So it gets key events, the mouse events. So, and then one of the things that a input receiver is given is it's giving individual events. Like if I press escape, it gets a discrete event for that, and this method gets called. But also on at regular intervals, this process method is called to process like persistent input state. Like if a key is being held down, right? Like W to move forward, this thing's going to get that. And so it's going to query which keys are being held down, decide on what movement is going to be applied, and also there's a time delta. Because if you want to maintain a consistent velocity, but this is called at irregular intervals, you've got to be able to figure out, well, how far how long has it been? So you calculate how far to go. So I'm computing so what I'm doing here is I've got things like move forward that instead of given a distance are given a time, and I multiply the time by the speed, that gives me distance, and I pass that on to the model. So I have a speed, I also have a sensitivity to mouse movement causing rotation. Yeah, probably went too deep on that.
No, it makes sense. It's good to understand how the whole keyboard or mouse input is done, because that's probably one of the most annoying parts if something is not working to get. Yeah.
So now I guess I was thinking I want to go. So that was like kind of at the bottom. All right, I'm going to go way to the top because and it's similar to the way Minecraft does this. There's a world. And whenever you want to do something like place a block, you tell the world to place the block, and then it figures out what to do with that. Like, okay, I got to look up the chunk. I might have to generate a chunk, and then what information do I have to pass to the chunk? And then the chunk figures out what to do in order to put that block into the world. And so that's what this is. This is the top level data representation of the world, not the visual representation, but how it's, but which blocks exist and where.
The model of the world.
Exactly.
Yes. I see.
Yeah. And so
and not so rendered stuff.
Right. And then this will eventually contain like a list of entities, or maybe the chunks will. I don't know. I haven't decided. I'm pretty sure Minecraft used to track entities per chunk, and that caused all kinds of problems when chunks disagreed whether or not a given entity was contained in them. So I don't know. But then you have the problem of which chunks are unloaded when you unload a chunk. I don't know. I haven't figured out how I'm going to deal with that. I definitely am not going to look at how Minecraft does it.
It's a very hairy.
Yeah. So I'm actually using the Java concurrent hash map because when I looked up what's the best Scala solution to having a concurrent hash map is the Java concurrent hash map. So I have a long, which represents a packed representation of a chunk's location in the world, and you can use that to look up a chunk. And this is maintained by, it's you load and unload chunks in and out of the structure, and this is where you look to find a chunk. And so we can go look at something like set block, right? Or that might be a good thing to look at. Where's set block? Right. Okay. So what do we got to do to set a block? Well, we're going to get the chunk, and then I'm using Scala's option mechanism. Instead of returning a null, I return an option that might be some chunk or none. It's just a preferred style in Scala. So I'm looking up the chunk, and if I got the chunk, if I don't get the chunk, that could mean that something decided it shouldn't be loaded or it doesn't exist or some problem, so I'm just basically going to bail out. But if I have the chunk, then what I can do is tell the chunk to set the block. And then I've got to maintain, I've got to queue up what happens to the neighboring blocks. Like, so setting this block is going to,
what if the chunk doesn't exist as in it's not been generated? Isn't that part of it? That seems like it just bails out.
Well, get chunk will generate the chunk if it's allowed to.
I see. So that should by any means that chunk should have been returned. I see. Makes sense.
Right. So here, I'm setting a block, and this is an individual block, and so I'm going to assume that if I'm setting a block, I want to load. Okay, so there's all of these things have the option of saying I want to do this thing unless the chunk is not loaded, and then I want to do nothing. Okay, because there are some things that involve visual updates to blocks that kind of need to do that. If like something happens at the edge of the world, you don't want to infinitely load chunks because you're gonna do something visual on a chunk, and then you got to do something visual on the neighboring chunks and the neighboring chunks, and okay. So, but if you're doing a set block, this is like a user input saying I want to place a block in the world, and if that has the effect of loading a neighboring chunk, then it makes sense in that case. So that
makes sense.
And I've got to update things around the chunk. So there's two kind of things. There's a block update, kind of like Minecraft's block update. I haven't really fully defined what it is, but it's like whatever does the block do when it's told, okay, something nearby happened, and like redstone gets updated or a piston moves or something like that, right? The idea here is, none of this is implemented, but is basically the block update event from Minecraft, right? But my way, I'm not copying Minecraft. And then, but there's another kind of event that can happen that is a visual. You can create a visual representation. Like, let's say that, like take a fence post. If the fence post in Minecraft does not have a neighbor, then it looks different from if it has a block that's a neighbor, right? And so that's what the repaint event is going to do. It's going to tell you something near you has changed. So you might want to go look those things up and modify your visual appearance so that when you're rendered, right? But this is this is a state thing, right? A mesh that isn't drawn is still a visual representation of the block. So, like, I'm not sure how to deal with this in multiplayer, but I feel like I need to define a wire protocol that doesn't represent the world in quite as much detail as Minecraft does. Like in Minecraft, you have full representations of the blocks in both the server and the client, so that and one of the important reasons for that is the user moves around and runs into things and whatever, the client the user is client side controlled and therefore needs to not walk through blocks. Or not continue walking and then discover later that the server said, no, you can't do that, and then revert you, which does happen sometimes if it rubber bands you back, right? So I need to come up with some way of maybe providing less information to the client so that you have I'd like the client to be more lightweight than Minecraft's client. But you still have to have enough geometry information about the world to know what to not bump into. So I don't know. I'm way far off from getting into any of that. So we've got get chunk here. So you can tell it I don't want to load the block, right? By default it does.
Yeah.
This position could be a block position or a chunk position, and I did this because I couldn't make it polymorphic on this, like have two separate methods for some reason. I can't remember why, but I ended up not being able to distinguish at compile time between chunk position and block position for, like I said, I can't remember why. So what ends up happening is if it figures out whether you're passing a chunk or block position and does the right thing. All right, so and if it finds the chunk and it's going to return it, and otherwise it's going to try to load the chunk. Okay, so and here we have, now this has to be synchronized. We don't want multiple threads accidentally generating the same chunk at the same time. So this requires synchronization. So like if you're the first person through, then you won't find the chunk. You're checking again for the chunk. You won't find it, so you go and generate the chunk. And if there's a second one to get through this lock, then you're like, oh well, all right. Since the time that I got blocked on this, that has already been generated. So it'll do the right thing there. And so that's kind of like a superset of what getBlock does. getBlock just does less stuff than setBlock. And then we have things like I want to apply an action to a block. I want to right click it or left click it, and it will find the chunk. And in this case, it does these things do getBlock. It wants a specific block, and so it gets the chunk, and so the get chunk might return an option. So I use map, and what map will do is if it's none, it will do nothing, and if it's some chunk, then it will call getBlock on the chunk. So inside the chunk, we have a way to turn a block position into an index. So the chunks are 16 by 16 by 16, and so you get an index into the block storage right here. Okay. And then,
because it's what is called cube, is the world limited by any specific limitations, like vertically or horizontally?
No.
Or is it infinite in both directions?
So there's nothing here that limits that. I may limit it artificially elsewhere, but this chunk, it knows where it is in the world. But the like bottom left whatever corner of the coordinates that are what define the chunk position could be anything. Could be positive, negative, as long as it can fit in a 32-bit integer. Then it's valid. So you could have a world height that's whatever the heck you want it to be. There are going to be some limitations actually we want to pack. I do like Minecraft does. My packing is different from theirs, but you take the X and Y and Z coordinates of the chunk of the position and you pack them into a long that you use as an index. Okay, and in this case, we're only using the lower 16 bits of the position, so it's basically 4 bits, and the next 4 bits get shifted left, and the next 4 bits get shifted left. Those get ORed together, and that gives you an index into the block storage. So we get an index into the block storage. Then we're going to find out how this block is implemented. Like, what is it? So I have a separation between a block's implementation. So here we have an abstract class that lets you interact with a type of block, right? So if let's say you had a chest, okay, then I'm going to have one class that represents chests, and any persistent data like the inventory of the chest will actually be stored in the chunk, so that when you save the chunk, then it gets serialized out. Okay, so the implementation of the block isn't going to store the inventory of the chest. It's going to know that it has to look up the inventory from the chunk when it wants to deal with that inventory and modify it in the chunk. And so the block implementations are stateless. They just represent functionality. And so they provide things like the visual representation, and by default, it returns the default mesh. Like, some blocks could change their appearance, like in Doctor Who, and some blocks don't, right? So they only have a default mesh, and there's have collision. So you have a hitbox basically. Well, you have collisions and you have hitbox, right? Collision is, can you run into it? You may have a block that you can walk right through, but which you can hit, right? So and anyway, so when you want to left click a block, for instance, this thing's going to get called on whatever the implementation is, and you're going to be passed a block. Now the block is an ephemeral representation of a particular block that you've asked for. Whenever you say, "Hey world, I want a block," Well, the representation is distributed through in different data structures in the chunk. And so what happens is it gathers that into one object and returns to you that representation of that particular block. And then you can ask that block, okay, what's my implementation? Sometimes it needs to look up the storage index so it can refer to its own information in its containing chunk, so it knows what its chunk is. It knows its position in the world. You can figure out which faces are visible. All these things that pertain to a real block. And so when I want to right or left click a block, then this thing, you're actually going to get the block and you're going to tell the block, okay, I'm going to hit on this face. And what it's going to do is it's going to turn around and tell the implementation that there's a hit action, but it tells it, oh, here's the block that the hit is occurring on, and then the implementation will use that block to look up the chunk to actually get any persistent state. Like, so if you right click something to change its shape in some way, I don't know, like
it seems similar to
visual
Minecraft
representation or whatever. Yeah. Then that information is the block implementation doesn't know about that. It knows it has to look it up. So anyway, this is how you apply all the various events to a real block. But this object, we'll end up with the same problem that Minecraft does, which is that these block objects will be created at some absurd rate, and so I may do something here that Minecraft didn't do, but which I modded into Minecraft, and which is to cache block objects based on their position. So if you look up the same block multiple times, you'll actually get the same object instead of just having it get garbage collected and then recreated. Actually, I did that.
That's smart.
I actually did that with. Actually, I didn't do that with block. I did that with block position. So block position. And so the guy who what's that visual mod? The really popular one.
Optifine?
Yeah. So the author of Optifine had this complaint. It's like 50 megabytes per second of block position objects are created. So I created a cache for block position. I mean, they're immutable, so there's no problem of returning the same object twice for the same block position, right? So and what I also did was I cached neighbors of blocks. So if you looked up a block position, then you could find out what its neighbors were with no cost if they were already known. And this actually that the block neighbor thing sped things up quite substantially. I also separately implemented a thing where you could ask, instead of looking up each neighbor separately, because Minecraft had this code that would iterate over the faces of a block. Okay, but looking up the neighboring block on a given face is expensive. So what I did was I rewrote all of those to look up all of the faces in one shot, returning you an array of block positions that you could then iterate over, and that actually had a significant performance advantage. But caching the block positions, all that did was it dropped the GC load. But if your garbage collector was, the garbage collector tended to do such a good job of keeping up with the production and destruction of these really short-lived block position objects in the the Eden category of blocks, that it really wasn't a problem. So we could see when running my mod of Minecraft that it wasn't any faster. It just had much lower GC load. So anyway, all right. What else do I want to say about this? Okay, so and if you have any questions, of course, you feel free to
of course,
pop in.
But it seems like a very straight up this portion of the get the block positions, and they're very similar to Minecraft. I think it's like if someone is familiar with the code from Minecraft, the world data structure.
Yeah, and it's hard to say. I'm sure that some of these ideas came from my from years ago, my exposure to old versions of Minecraft, like 1.12.2, decompiled by MCP, right? But a lot of things that I put in here come from ideas that I came up with as ways to improve on the way it's done. Okay, so now it turns out
that makes sense. Yeah,
that some of these
experiences that probably like they've made mistakes on architectural mistakes. That's
right,
legacy code,
or just caching that they wouldn't even consider doing, stuff like that. Like I haven't implemented caching yet on getchunk, but I will, because it definitely is a performance advantage, because I tested it in Minecraft, implemented it and tested it, and it was a distinct performance advantage. And so I told Grum this, and so I was caching multiple most recently accessed chunks, but he found that caching the single most recently accessed chunk, so you just like, is this the same chunk that I just gave you? That's handles he didn't tell me the statistics, but it probably handles like 90% of the cases or better, so it's probably good enough to just cache one. So if I implement that, that's not me copying Minecraft. That's Minecraft copying me, because he literally did this on my suggestion. Okay, so so there's some of these things that I do, like get blocks plural and get chunks plural, where in the C++ version there was a distinct performance advantage because I could take a lock once, do a bunch of work, and then return all of the results of that work. But in Scala, because of the relatively low overhead of accessing the constant overhead, I wouldn't say low, but the essentially constant overhead of accessing the concurrent hash map, some of these things might not, like there isn't any particular optimization. Like I'm going to look into it later to see if there's some way of knowing all the blocks that I want. Okay, go give me all of them. If there's a way that I can make that perform better than just fetching them one at a time. So, and in my, in other work that I've done, I have found that even if you do just iterate like this, the further down in the call stack you can push that work, the better, because you don't end up making the same chain of method calls over and over and over again. The
hops, the number of hops you need to do in the lower layers is better.
Yeah. You basically, instead of having, you want 1,000 blocks, instead of taking 1,000 traverses through several layers of abstraction, you make one, and fill an array and come back. Yeah. Right.
I think if you're really familiar with what is it called, the like low-level hacking, bytecode hacking and whatnot, stuff like this becomes really apparent, but it's completely abstracted away on the upper layers. Yeah.
So one of the things I'm trying to do is try to keep all of this lockless. So like there's things where in order to do something, you're doing an atomic operation. So one thing that Minecraft does is it natively stores chunk data as the most compact format that it can in memory. And that makes sense because they want to fit more chunks in memory without bloating the JVM. Now, what I'm doing is not that. And it's probably a mistake, and I'll probably fix it later. But right now, I just store it in an array of shorts. So if you want to replace a block, then you can, without any kind of locks, you can atomically replace a block, right? You can atomically replace a mesh. You can atomically replace any of these things just by changing a reference. And so I'm trying to strive for that, so that if multiple threads are trying to operate on the same chunk, that there won't be any serious thread race conditions that arise from that. We'll see. So another thing we can look at is the world view. So now this is what manages and creates the visual representation, right? So if I have a client-server situation, then world would exist in the server, but world view would not, or maybe some radically stripped-down version of it. Whereas the client would have minimum information in the world and concentrate on the view of it. And of course, in this case, it's single player, so the separation, things will change, but the separation isn't as important here as it will be. So, so I have this thing that gets called from a thread, which is this. Okay, so there's this thread that whose purpose is to whenever a block is modified in a chunk, and you need to recompute the visual representation of the block and the surrounding blocks and all of that, then I'm offloading that to a thread. So it could take a while to actually achieve the effect, but it's not in the critical path, so it's not lagging things too much. Like camera movement isn't going to be affected by any slowness, okay? And this thing's actually woken up once per frame, right? So if the the time to take to render a frame is long, so you're getting visual lag, then this will occur less frequently. The wake up will occur less frequently. And so there is some synchronization, loose synchronization between the video thread and this thread, because it calls notify to whenever it's time to look for visual changes of the world. Okay, so then this thing gets called, right? So that's compute chunk renders, and it gets some geometry information. It computes a view center and all this. Now the view center, by the way, has to be computed here. There's an interesting thing that I have had to deal with. Between the time that the visuals are computed and when they're actually displayed, the camera could move. And as a result, you could end up with a different view center. And you have to render things relative to the view center against which they were originally computed. So we calculate a view center here, and then we pass it through everything, and then use this view center later, even if the camera's moved. Because the camera can't move that far, right? The camera moves a few blocks. It doesn't affect the round-off problems with single precision floating point. So we iterate all the chunks, we get the view, get the projection, set the projection matrix that we got from the window, and then we compute the visual updates for the chunk. Okay, so so first we look to see if the chunk is even visible. So there's this elaborate math to compute whether or not the chunk is even viewable from the perspective of the camera, right? Does any of it overlap the camera, or does none of it overlap the camera? I've seen bugs in Minecraft where if you turn just a little bit wrong, you see like missing chunks in the distance and things like that.
Oh, yeah.
I think I might have done a better job here on this. Like,
I think that Minecraft's implementation of visible chunks is
right.
It's nothing to like. It's not a good place to take like inspiration from.
Well,
it's messy.
I did all this myself and implemented it in C++, and then just pretty much copied my C++ code and ported it. But yeah, so I had to go figure out like what vector math had to be done in order to do this, and it's probably not really super efficient, but I tested the heck out of it and it works really well. So all right, so if the chunk's not even visible, it just skips recomputing it. Then it goes through and figures out which block faces should not be shown because they're between adjacent fully solid blocks. Then I figure out what I compute what I'm calling render mesh renderers for all of the opaque blocks, and those are really the ones we'll need to care about here. So I've got these arrays. I've got arrays of chunk of mesh renderers that are per texture. Okay, so instead of making one giant texture atlas, each block texture is its own texture. So what I do is I go find all the blocks that correspond to that one texture, make one giant mesh that represents all of those blocks, and then I go and I iterate through the chunk and find those blocks and, make sure it's not a translucent block, and I check to make sure that it's the texture that I want, and so on. And then I'm making these lists of the block position, the mesh that of the block. So basically the mesh of the block is going to get added to a bigger list, so that we have a really big mesh that is the combination of all the little ones. Okay, so in one big shot, I can, in one draw operation, all of the blocks of the same type get drawn at once. Okay, so I'm basically making these lists of block position, mesh, and which faces are visible, and then I can pass this to this load meshes method that I talked about last time, and that builds this mesh that then can be rendered. And then what I do is I've got two lists. I've got the list I'm operating on in one thread, and then I've got the list that needs to be rendered in another thread, and I do an atomic swap, basically, of these two lists, so that when I'm done computing this list, the render thread is either going to see the old one or it's going to see the new one, but it will not see something that's partially constructed. And then I also do, so this is opaque renders, and then I have the translucent ones. Where is that? Well, anyway, this is the code that actually, that's update block faces. The update block face is kind of interesting. So given a block, it looks at all of its faces and finds the neighboring block, and if both faces are solid, that my face and your opposing faces are solid, then it can delete it. Unless it's translucent. If one's translucent and the other one isn't, then you can't do that. But if you have two translucent blocks of the same type that are neighbors, then we delete the faces in between, because otherwise they look like separate blocks. Whereas with glass, what you kind of want is like a continuous unbroken piece of glass without any like weird like little faces inside of the glass, so that this handles that. Maybe at some point I can show an example.
Maybe an
of
example.
That. Yeah, I can't really do it right now because I haven't even tried doing translucent blocks yet. It would take me, several minutes or more I'd have to go get a texture that had some translucency, and I'd have to program it in here, and I suppose I could do that live. It depends on how much time we have at the end. Okay, anyway, so basically I end up with one mesh renderer per translucent block, because they had to be sorted in order of furthest from the viewer to closest to the viewer. So if you got a
OpenGL stuff.
Yeah, well, I have to sort the blocks. So OpenGL, when you can render, if something's opaque, you can render in any order because it's got a Z buffer, and if you render something behind something that's already there, then it just doesn't draw it. But if you render a translucent blocks in the wrong order, then it looks really weird. Like you want to, if you're looking through a translucent block at another translucent block, then you want what you're seeing to be filtered through the nearer block. So you have to draw the nearer block after the farther block. So what I'm doing is making a list of all of the individual translucent blocks, and then what the worldview is going to do is it gets all of those things from all the chunks, all those renderers, and then it sorts them in the order of distant to near, and then it renders them in that order.
Makes sense. So you just have to arrange them in the correct order, so the OpenGL calls are correctly called.
Yeah. So I have to, hopefully I did it right. In this case, the mesh render needs to know what its coordinate is for the translucent block, and like here, Yeah, and I do it. So I compute a trans sort position, which is the dead center of the block, and I put that into the mesh renderer object so that when I go to sort them, it has a reference for where that block is, and it's just sorting by compared distance. So yeah. So I mean, I think that kind of covers the main functionality of the worldview. It's a render agent, so it gets called to draw. Will render. Right now, I just hacked it to be true. I'm not bothering to check to see if I don't need to render anything. This calls the draw method, which
basically the world view rendering, the very
mm-hmm.
top layer.
Yeah. So this does the GL stuff indirectly. Turns off blending. Renders all of the by chunk. Renders all of the blocks in each chunk, and then globally turns on blending and globally renders the translucent blocks. Because I think turning off blending, I'm going to guess, will perform slightly better when you're drawing things that don't have any alpha channel. I don't know. And then, so here I've got a basically static method that computes if something's outside the frustum. And I don't remember how this works. I probably have notes somewhere where I figured it all out. And
it's magic. You just trust it.
It's not. Yeah, I mean, it kind of is like that. It's magic in the sense that I've completely forgotten how I came up with this algorithm. but
I bet there is like an algorithm out there. Someone can probably copy pasta.
That's probably better than what I did, but this works. So.
Oh, I see.
Yeah, and this is only done once per chunk. Actually, no, it's done more frequently for translucent objects. So as long as you don't have too many translucent objects, this won't become a performance burden. But yeah, so basically it can figure out if a given block position is inside or outside of the chunk. And so for a given chunk, you have to check each of the 8 corners of the chunk, and if any corner is not outside of the frustum, then you render the whole chunk.
Oh, okay, that's smart. Yeah. So anything that is visible, any corner that is visible makes the chunk visible.
Mm-hmm. Yeah, and I think there might be some false positives on it. I can't remember. I think like you can. I had to do some. It's not quite this because I had to make sure that if the corners are outside of the view frustum, but some other part of the chunk is visible, it still has to be rendered, and I cannot remember how I did it, but I did solve that problem, and this is just a port of that code. Yeah, and so this is just like iterating the corners of the chunk. So for that.
But it can be trusted. It works.
Well, yeah, I mean, unless I screwed it up. Yeah. Let's see. What else I want to talk about? I have a list here. Okay, so we talked about chunk a bit. And so there's a few things that can be done here. Normally you have a default mesh for the for a block, but if a block's implementation wants to replace that mesh, it can, and that will get returned. You can, for a given block type, you can look up its implementation. Well, you have a conversion from block ID to implementation. So I think, yeah. So this is like the upper bound. Chunk storage size is like the maximum number of different types of blocks you can have. The array is actually much larger than it otherwise needs to be because there are only as many block IDs as there are block types that have actually been put into the chunk. So block types are handled by string name. So I have a map from the name of the block to an ID number, and that ID number is per chunk. So each chunk is basically going to track its own ID numbers for each block. So this way each chunk storage is compacted. Like it doesn't know about a block. It doesn't have to keep track of a block type that exists in some other block, but not in itself. And that makes the block IDs unique to each chunk. But we have these tables to look them. We have these structures to look them up. So there's a chunk. There's a chunk view. You know what that is.
Yeah.
And so we can get a mesh.
The word is probably like very descriptive. The viewer.
Yeah.
That chunk.
Exactly. So the implementation can set a mesh, and then it'll start using that. I can convert an index to a block position. That needs to happen sometimes. I can get. This looks up. Give me the name of a block. I want a block of wood. Okay, go get me an ID for it. And if it already knows about it, it gives you that ID. Otherwise, it creates one. So it looks in the block library, which I think I might have talked about last time. No, I haven't. So I'll get to it. But anyway, this keeps track of all currently known blocks in the world by name. Lets you look it up, and you get the implementation of that block, and then you can use it. So that just stores that into the chunk. There's more than one way to get the block ID. So if you know the name, then you want to look up the implementation. If you know the implementation, then you don't want to do extra work to get something you already have. So I have code duplication just for performance reasons. Let's see. So you can get the implementation of a block based on an index of carefully semantically distinguishing between an index, which is the chunk based on its position in the block, versus an ID, which is the type of block it is in the chunk. Okay. So to get a block, you're going to convert the position. So if you get a block by index, then you need to get the position because you're going to create one of these block objects. You get the implementation and you fill out this object, and then you can return it. So that's why these are ephemeral representations of a block that you're trying to look up and do something to. I also have a nullable version that will return a null instead of error for a block that doesn't exist. This has potentially some use. So here's get block based on position, which is
And I think Minecraft returns error by default instead of a null block. That's
right.
From I remember, yeah.
Yeah, so this one returns error by default unless you asked for it to return a null for error instead. Because 0 is locked as being error. Every chunk.
That's kind of a confusing part, which is what if you wanted to make a default that is non-error? That would be that I've always thought.
Sure, and suppose you could do that, but that's unusual. And so sure, you could hack it to do that. Okay, so.
Oh, but there is no support for that. I see.
Yeah, here. Well,
but
here.
In this instance, it's like defaults to error. Yeah.
Right. So, and here, this one's actually used get block nullable. Like there are certain things where you just literally want to skip over error. You don't want to do anything with error. You don't want to call methods on error which do nothing. You don't want to waste the time on it. You want to say, is this an error block? Okay, I'm just going to inside of this inner loop, I'm going to skip it. So that's kind of an important optimization. Here we have set block, so we can set the block to some block that we pick. So of course it gets the block, and now it has a block object. It can break it, and then it can create a new one and place it in the world, and so on. And for new blocks, it generates place and repaint events. Update block. This is a block update, kind of like in Minecraft. Update all blocks, sends block updates to all blocks. So if you set one block, then you're going to get a block update event for itself and its neighbors and everything. Okay. If you're generating a chunk, what you want to do is generate all the blocks without any overhead of dealing with neighbors, and then deal with all the neighbors all at once in bulk. Right. So if you did set block when generating a chunk, you'd end up generating huge numbers of redundant block update events, whereas you just want one per block. Says
I think Minecraft doesn't deal with that really well. That's interesting. So in this instance, it's the same thing where you don't go and do multiple lower layer calls. You just do one giant optimization.
I think it does better than it has. You there have been bugs in the past where clearly some neighboring block. Okay, like for instance, I've seen bugs where, for some reason, the lighting around lava didn't update anything, right? And something went wrong where it didn't do the block updates right during chunk generation. So there's all kinds of weird things that can happen during chunk generation that don't lead to updates. Okay, so anyway, this one's going to do that in bulk. So a repaid event. This is an actual repaid event where it's basically telling the block to maybe change its appearance. And then we schedule it to be re-rendered, and then for repaint all blocks, then it's going to make a list of all the blocks, and actually it's not going to update them now. It's going to schedule them to be updated in another thread. So whether a block is updated immediately, or later, kind of depends on when it's happening, right? So if you actually set a block, it's going to repaint it in the critical path. If you do something in bulk, it's going to repaint it in a separate thread. So gen block is like set block, but it's much simpler. It doesn't actually send any events because those get sent separately. We have.
That's really smart. I really like that idea over the Minecraft implementation.
So we have, like this thing's used a lot. Okay, the block's changed. So we're going to queue we're going to queue some work for later to actually update what it looks like, right? So there's a repaid event who decides what it's going to look like, and then when that happens, it's going to schedule an event in this update render thread to generate the render meshes that correspond to the visual change. And then in the video thread, it's actually going to draw it. So I haven't implemented loading and saving yet. And the generate is just filling out a couple of blocks. So we could change this to, I made a steel plate. So
what's generating the world?
Yeah, it's compiling, and so then I can, here's my steel plate. The higher res version I did in the C++ version looked better. This looks like kind of crap, but what else do I have? I have wood. Oh, my cobble's pretty decent.
So these are the blocks that you've placed in the
these are
the YAML?
Well, exactly. So there's cobble.
Why is it called YAML?
Yet another modeling language. It's kind of like JSON, but another way of representing the same kind of data.
I see.
I think I might write my own parser. I wanted to read these things sequentially, but what the YAML parser wants to do is just give you a map from key to value, which loses the order. So I had to do some weird hack to even be able to get them in the original order. Because there's a hash map the linked hash map keeps track of the order, so you can iterate it. Because what I want to do is be able to say, okay, all right, this is the only thing that's different from all other blocks. Okay, so the first thing I'm going to do is say I'm going to rely on a pre-existing definition of an untextured cube, and then give it a texture, right? And so for the untextured cube, all the faces are solid, but I need to include cube faces. The texture coordinates and collision box. And so here's the collision, here's the cube faces, like coordinates for the cube faces, and this is the texture coordinates. So cobblestone, for instance, only has one little texture. Like, can I show it? Right. And it doesn't have different textures for different sides, which is it's supported by this. I just didn't do it here, and so basically because of that, I have a uniform cube texture that refers identically to the same texture for all faces. And it's just like you could include that, or you could include a different one that implements separate faces, separate parts of a texture, where you can have a texture instead of being 16 by 16 is 16 times 6 by 16, okay? And then include in there the coordinate, each of the different faces, and then you can have a file instead of uniform cube texture have some other name that is for this kind of situation with multiple different faces, and then you can just include that. So anyway, so I can because of this whole include thing, and I wanted to do it in order, I had to jump through some hoops. Otherwise, the includes would not be the first thing in the list, and it just was kind of messy. So anyway, point is, now that I've replaced it with Cobble, then we can see that I took advantage of Minecraft's, or not Minecraft.
This looks so beautiful.
GIMP has this thing that will let you take a texture and like make it tileable, and usually it makes things look terrible, but it did okay here. So this is my cobblestone. So
it looks beautiful.
Yeah, I found.
It doesn't look like cobblestone. It looks more like set block. Set.
It's like tiles.
Like, stones.
Yeah, stone tiles.
Like perfectly.
Yeah.
Stone tiles. Yeah. It looks more beautiful. Like it does look like actually like stone that is like small and cobbly. Looks perfect.
So anyway, so that's how I've been testing those things. And this is the get corners for frustum culling, and some constants, and conversion functions, and so on. Okay. So that's yeah.
I'm not sure if did you go through the entities as well?
I don't have entities fully implemented yet.
So, it would be nice to see what is inside of that entity ball.
Yeah, I'm good. That's going to have to be a later thing, because like right now the entity like isn't even finished. I cannot put an entity into the world. Okay. And the way I currently have it, it wants to maintain its own visual representation, and what I really want to do is move that into the world. I don't know. I haven't fully figured it out. Most of the code is ported from the C++, but you'll not, well, actually no, because look, I have all these things where I was going through the header file in C++, and I know that there's an implementation in the CPP file, but I haven't gotten to it yet. So there's a whole bunch of stuff in here that just isn't implemented yet. Like the motion thing is this. I ported this from C++. It figures out, well, actually it's not even finished, is it? Anyway, yeah, that's not finished. There's a whole bunch more code that has to go right here. So that's still a work in progress. Okay, so is there anything else I want to talk about here? No, I think I've pretty much covered chunk view. There's drawing of the chunk, does the frustum checking and all that. I think I've shown this before, computing the visual updates. Okay, so you can move on. So there's the block library. It's kind of like the texture library that where you say, all right, I want to look up a block type, look it up by string. It's going to see if it's got it in the library, and if it does, it'll return it. Otherwise, it's going to load it, and that uses the YAML thing. So in this case, so far I'm only supporting this static cube block, which is just any generic cube with a default texture, with a default mesh. Right, the textures are different, but the meshes are the same. So you can also like poke in a block type, but this is for these static cube blocks, it's actually dynamically loading them. It's like if I gave it a block name that didn't exist, it would just crash because I haven't handled that
that's
case yet. So, I mean, because it just assumed.
I mean, that does make sense. Like,
Yeah.
at least it doesn't crash right off the bat.
Right. So I'll fix it. Eventually. Let's see here. Here's the. Did I show you the block implementation class? I think I might have gone through this a little bit. It's basically the super class that you would use to implement like a block with actual functionality, right? So this static Q block implements that, okay, and so does air, right? Air like really is absolutely minimal, right? It's got literally here's my empty mesh, and it's an object. It's not even a class. It's got nothing but static members, okay. So if you try to render air, like it returns nothing, so does nothing, right? It's but it's one of those ways that you make the thing not crash by returning something valid that has no side effects. So I talked about the block object. I talked about static Q block and air. So I can go through main a little bit. So I got world and a view, window, camera, crosshair. This test block isn't being used.
Crosshair is something that you didn't talk about.
Here, I can show you the crosshair. Okay. So, all right, let's see. World view. This is the thread that updates that does the repaint events. This is the thread that recomputes the visuals of the blocks change and you want to compute new meshes, right? And that thread does this, and it's actually added as a renderer agent because you want to call it, and it's added as a renderer agent with the highest priority value, which means it's done, or is it the lowest priority value? Anyway, I can't remember if I made it happen first or last, but the point is that this thing is woken up by once per frame, so that it can go and calculate the stuff for the next frame. It's woken up, like it doesn't run in the video thread. It's told to go do its work in the background once per video frame. Okay, so here's the crosshair. All right, so the crosshair is so I, instead of putting these things in files, I just went ahead and embedded them in text because it was one of the earliest things I did. It's a render agent, so it has to implement certain things. So it creates a shader, providing it this shader code. It has resources that need to be destroyed. There's this handles thing that I mentioned last time in this utility. It keeps track of the VAO and VBO things, and it makes it possible to dispose of them. So that happens here. There's memory associated with it. It contains the points, and so when this thing is destroyed, it can free up all of its resources. So there is when the window is modified in its dimensions, then we can compute a plus sign. The horizontal and vertical.
So these are the basically the literally graphical.
Yeah, these are just coordinates on the screen.
Points.
Exactly. And in an orthonormal coordinate system, or like say the physical coordinate system, there's no projection matrix applied here. So there are no matrices applied to this. There's no projection. There's no view matrix. It's just drawn in the device coordinates. So when we get a resize, we recompute the points. The priority is -1000. So I think, and obviously it's rendered. So I keep having to try to remind myself of what order I decided to do it in, but I think it sorts in the order from largest priority to smallest priority, and I want this to be rendered last so that it's on top of everything. So there it is. I'll once I have menus and stuff, I'll change that.
Yeah, probably this is probably going to be below menus or some sorts. I see.
Exactly. So what else? Is there anything else in main that I can talk about? right? So I add that as a renderer. This is here to cause the world to generate. If I didn't do this, then that chunk that you see wouldn't generate because I don't have automatic user coordinate related chunk loading and unloading, which is something that does need to be added. Okay, so here's the render loop. So we spend the rest of eternity until we're going to quit the game inside this render loop, which is why I have all these other things that I want to be done once per render iteration that are fake render agents like that disposer.
So there is one question: is if the render, if you spend the time in the render loop, isn't there supposedly a world loop where it updates the entities and the objects and stuff like that?
Yeah, and that would be in a separate thread.
Okay. So this is the main. This is the main for only the rendering aspects, not for the world aspect.
Yes. So, like for instance, there's this thread whose job is to, So this is a badly named thing. It's for updates and repaints, and that's what this does. Okay. So it processes all queued block updates with and without chunk load, and also repaint events. And that's handled in this thread every 50 milliseconds.
And where is this called? Is this called in the main?
Yeah, this is just in main creates and starts this thread right here. And it's asynchronous to the world, okay? Like to the video. It's asynchronous to the video. And then, so block updates happen in here. And so that's
how the world rendering and the world updates are put in threads.
Right. And so I guess that I'll probably put like game tick events into here. So, I'll do something like the chunk knows whether or not it's got any blocks that need tick events. And then if it does, then it'll deliver those to the blocks.
I think it's very interesting. Most game engines that I've seen, like classical basic world game engines, they usually put the block updates and the world updates on the same thread as the visual like updates, so that they're on the same thread. They're doing but here you've separated them into different threads so that the renderer agent and the world is completely separated. That's kind of but it's hard. Is it easy to fall into the traps for synchronous issues, like where there is synchronization problems of accessing either blocks or something like that? So you can fall trap for that.
It's possible. I mean, I'm pretty decent at knowing, like writing lockless stuff. Like I'm doing these. In the C++ version, there are a whole bunch of some hoops I had to jump through to be able to like atomically replace pointers and things like that. But the way I'm handling a lot of these things is there's something that needs to be updated, and it's all or nothing, right? So if I'm updating the visual representation, like the mesh, like which meshes are going to apply to things in the world in one thread, well, I want that whole chunk to either get rendered or not rendered. So I either want this one to render or I want its predecessor to render, to be displayed. So I have kind of a pipeline here of, there's in one thread, things that will make decisions about what blocks exist and, like block update events that may cause some visual changes. Like if there's a piston and it needs to push and this blah, 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 this stuff happens. Okay. Those will happen because of block update events. And then those will cause blocks to decide that they want to look different. And that gets queued so that another thread will come along and turn that into meshes that can be drawn. But it does that in an atomic sort of way, okay, as such that when the video thread comes along and says, okay, I want to render stuff, it's either going to get a new version or the prior version, depending on how the threads, because you can replace an object reference atomically.
So it's 3 threads involved.
Yeah, and
one
there'll
of the
probably be more.
render, one of the world,
Yeah.
and then there is the one.
And I'll probably do a lighting thread.
Interesting. So it's going to be multiple threads. So
Yeah.
it seems very like abstract and complicated. Like for me, threading is something that is easy to like fall trap for and easily like cause concurrency issues. But
Sure.
it's interesting that you've implemented it here. So it's going to be really interesting to go through it in detail to figure out how all that blocking and accessing is done.
Yeah. So yeah, what I'm specifically trying to do is ensure that state changes always are sort of like atomic. You do a bunch of work and then atomically replace what it used to be with the new thing. Now, there's things that probably are not quite there yet. So like with chunk, if you want to look up like this, I'm going to have to add locking to this. Okay. If you do a set block and you want to get the ID, okay, so get block ID, all right, then that is going to if this entered twice with the same name, or not even with the same name, but if this got entered twice in 2 different threads, they could stomp on each other big time. So something like this is going to require some locking, right? So the get.
Oh, so everything is not perfectly locked yet.
Right. Yeah. So this is missing some locking. So like this should be lockless, probably. But I basically need to come up with a way to only lock when a change is being made to this structure. And then most lookups of pre-existing blocks can be lockless, but anytime a new block is added and that requires state change updates, when you have a maps are nasty. Like their internal structure changes. And so this thing is going to require that I do something different from what I am doing. Like I may need a concurrent hash map, or I don't know. I haven't figured it out. But this may be the point at which that whole bulk thing that I was talking about becomes necessary. Like set block. Like let's say maybe this whole thing needs a lock on it, which is going to suck. Okay. Then in order to deal with that, I'm going to have a get block IDs method that takes an array of strings and returns an array of block IDs. And then it'll take the block once, do all of the work, and return the entire list, so that now if I do set block for one block, then it incurs that overhead. But if I do a set block of multiple blocks, then it incurs that overhead once for the entire list. And so what I'll have is an internal set block unlocked method that's private, and then I'll have an entry point set block and an entry point set blocks, and it will take the lock, call the unlocked method maybe multiple times to do the work, and then unlock. All right, so we'll amortize the locking overhead by doing things in groups.
Interesting. But it's not implemented yet.
It's not implemented yet. Yeah. So I suspect this is going to become, and this is probably the weakest point, right? These two. And so the optimization that I have that leads to these things being separate will disappear, because I'll want one single locking implementation and so on and so forth. So I'll deal with that. But this is the vulnerability here.
That makes sense.
Yeah, I mean
but it's not. It's in a to-do list.
It is. So, or I'll say to do.
Fixed threading.
Yeah. So, and then I'll figure out what to do. So, yeah. Because the annoying thing is that this structure won't change it won't change very much.
Until it's,
Won't change very often, but nevertheless, if multiple threads are doing set blocks, if that's allowed, then you could end up with both threads entering this method at the same time, and that would be bad. So I had to fix that. Whereas with the generation, I dealt with that by let's see, in the world there's the load. So you only load if the block isn't already in the structure. So I can do everything lockless in terms of accessing the map between it's a concurrent hash map, so it's always safe to access in multiple threads. And then if I want to modify it, I want to make sure that I don't load the same chunk twice in different threads, so the locking that needs to be done is just here. So we'll figure that out. Anyway,
but it's in the works. It's not perfectly synchronously locked.
Yeah. Like I said, I don't have entities fully implemented. There's a lot of work to be done there. I also have these things that I did to test, the first thing I did was I made a quad happen, and that was a pain to debug. I just created a single, I did use mesh renderer and stuff, so it's basically using all the low-level features, but it just draws a square. And then I went and drew a block, and got that working, single solitary block, and then all these aren't used anymore, so I just need to move them aside. But they're good references for how to do the really basic things. Anyway, so
before I have generic questions. You went through stuff that you already talked about, what stuff is in the to-do list in the pipe. Is there anything else that's that you were looking for to work on next before that's upcoming in the next patch?
Well, it kind of depends on the order in which I do. There's a lot of stuff that's in this C++ version that hasn't been ported, that I'll get around to porting. Like the ability to have, so in this version, the camera controller is an entity, which it is not a visible entity yet, but
which one is it?
In the C++ version, the old C++ version.
In the C++ version, is it?
So I implemented the camera controller as an extension of entity. It actually contains an entity, and the reason I did that is because entity has this really important stuff, the ability to walk along the ground. Okay, so this move method, there's a motion that the entity is being moved, but the entity needs to be able to do things like, if I'm trying to move into an existing block, can I do that? Right? So it's got to look up in the world what blocks exist and what it would collide with, and not go through things, but also if it's something it should be able to climb up, it's not a whole block, but a half a block step, then it can figure out that it should be able to jump that half block as it's moving forward. And, or, in this version, I supported things that were smoother slopes, it's roofing tile slopes and things like that, and so this calculates that, but then it's got to figure out, if I'm going to step up, am I going to hit my head on something above it, and make sure that doesn't happen. So I implemented all of that in here. So all of this kind of functionality that I know exists in Minecraft, but definitely am not copying the way Minecraft does it.
I mean, I understand it's a white room, kind of a clean way to do it, so that you don't fall in a trap for copyright laws or anything like that.
Yeah. So I know some bits about how it works because that bug 2025 or whatever, the one where
the clipping into blocks. Oof.
Yeah, the thing where like the item keeps falling and bouncing back up and falling and bouncing back up forever. That's a rounding error. Like the position that the client has for the item is different from what the server has. So the server has it as a double precision floating point, but the client has received it as a fixed point. And so all I did was figure out, okay, well, it only happens in negative X and negative Z directions, right? So it never happens in positive directions. Is because the rounding is always floor. Okay, so what I did was I figured out, okay, well, if it's on the positive side, then I do floor, and if it's on the other side, I do ceiling, and I was able to completely fix the bug. So rather than passing the double precision coordinates, which people kept proposing, I'm like, why? Why not just lie to the client about where it is? It's off by less than 1/4096th of a block, which is a distinction you cannot see. So just tell the client what it needs to know in order to look correct, right? And there's
That's a smart way to fix it. True.
There's a whole lot of things that Million could do that would fix these things where you just lie to the client. So here's an example: arrows being shot.
But I should mention that though. Like if you're making a game engine, just send the data properly. Don't do these nifty, quirky workarounds.
They are trying to compact the data stream, and I can see why that would be valuable.
I mean, data stream compaction 2020. Like we're past the Stone Age.
I guess. Yeah. Sure. I mean,
nowadays you don't need to worry.
Instead
of
64 bits, it takes 16. It can add up, I guess. But another one was shooting arrows, and you know how sometimes the arrow would land in a spot and then it would jump because the server and client disagreed on where it should land. And it occurred to me what you could do is see again, it's rounding errors. The precision of the trajectory information about the arrow that was sent from the server to the client has lower precision, and therefore is going to compute a different trajectory. So the solution is either send the data with the desired precision, or you lie to the client and send it a trajectory that will achieve the desired effect. So
that's true.
And you can know you can know exactly what the client's going to receive because you know what exact rounding math is being done in order to compute what the client does. And so you just, come up with a way to figure out how to tweak the velocity information in order to achieve an effect on the client that is closer to what it should do, right? And there's ways of doing that, right? And it'll always be inaccurate, but you could make it better. So, it's what's going to happen here. I mean, mind you, again, I'm just doing this for fun. Will I finish this project? I don't know. And if I do finish this project, who's going to care?
If you don't finish it, we will poke at you till you do.
Well, but if I do finish it, who's going to care, right? I'm never going to replace Minecraft. I'll have like 5 people who decide to use it, right? Or maybe you'll be lucky enough. Somebody will be like, well, I want to write a game, and a convenient voxel engine.
When you were doing showing me all of this stuff, this is probably not going to be like the most interesting Minecraft clone, but it's going to definitely be something that if you say once wanted to do some kind of a Java project or Scala project and make a game engine out of it, then this is pretty much except for the block states and the block the verbatim, those things that aren't really necessary, but the lower layer Java section, the rendering, and all the not so exactly block update stuff, but when it comes to the world engine and whatnot, that is probably very interesting. I mean, I would personally take inspiration if I were to try to look at look up how to build a game engine from scratch.
Yeah.
This is pretty much interesting in that case.
Yeah. Now, to be fair, the developers of LWJGL have also produced something that looks kind of like a Minecraft clone. Now, I don't think they have any of the entity stuff, for example, or that I think it's all cubes and nothing but cubes, and their textures are flat, and it's very simple. But they do have terrain. They have terrain generation, and so But that's like the licensing for LWJGL allows you to copy their examples, and I may like steal some terrain generation code from them in order to do my chunk generation. Yeah.
Let's go. I'm gonna wait right here. We're gonna pause the video while Theo is going to steal LWJGL world generation. In 2 seconds, you will see the world generation.
Yeah, I don't.
Theo, you got time right now,
no,
right?
Not yet.
Let's go.
I think that'll take me more than a few seconds. Yeah.
No, I'm like we pause the video, and then me and you we spend like I don't know how many god awful number of hours, and then we'll be back in a second.
Okay, you know what that would require is that I have to actually do editing on the video.
Oh, that's right.
Yeah, I'm too lazy for that. No, I'm going to just do what I did last time and take the file and upload it to YouTube and call it done. How long have we been going?
That's smart as well.
I don't even know how long we've been going. Does this thing have a timer on it? Well, an hour and a half. I think that's probably enough.
Yeah, that should be. Wow, what? I went fast.
Yeah, and my family's home, so I should probably stop ignoring them. So anyway, thanks again for going through this. We can do more videos when I add new content, and we can just cover that. Slowly we'll turn this into something semi-playable. And
Yusuf, the new YouTuber. He's going to become a full-time YouTuber, going to be uploading every day.
Yeah, right. No, I don't have time for that. There's one other interesting thing. So in this old version, I had this weird bug. I had bugs related to rotation. So block rotation is a characteristic of a block. So given a cube, there are 24 different possible rotations. And so it was just a number that is associated with a block, and it could get rotated in place just by changing the coordinates of the mesh coordinates dynamically. Okay, but I have bugs in how I do face removal that would remove the wrong faces, and I never figured it out. So I'm trying to decide if I want to do that the same way but do it right, so every block has a rotation, or I have another option, which is that when you load a block, that block can come with a rotation supplied, and the block loader will just literally manipulate the coordinates to swap faces around and provide you with a whole new representation of the block. That could work. The problem is that complicates the problem of having a block implementation that just was like, I want to replace the visual representation, but then it has to account for rotation. So I had to figure that out, because I don't know where I went wrong in terms of handling implicit rotation. But there's things that I want to have. I want to have rotation, so like in Minecraft has it to some degree, like stairs can be rotated in different ways. But and so for a given block in the YAML file, I would list these are the meaningful rotations of this block. Okay, and none of the others would then happen. And then I also am thinking about adding a tinting feature. Tinting. Yeah. So like I want instead of having like completely separate kinds of wood that have different or whatever, some kind of block that have different textures, we can make a block that's a tinted version of another block.
I think what you're referring to is like the classical old Nintendo games where they had like a black and white textures, but then you could color the black and white in different ways so that you could get multiple colors of the same shaped colors.
Yeah, and it's kind of like that.
That's an interesting idea.
So what I would do is in the in
That will be
the
like you're saying all these interesting things, and I want to see it in code, but like you're tempting us with this. This is tempting.
What I would do is modify the fragment shader so that there is a color that can be passed in that gets element-wise multiplied by the color that is being rendered. Okay, and so if it's all ones, then it does not change it. But if you want it to be red tinted, for example, then you would lower the green and blue components to something less than 1, and then and that would just get automatically applied in the GPU with no special work, with no extra textures or anything like that.
I see. So it would probably be some shader.
Yeah. This shader would get modified to support one extra operation in here. So.
Yeah, that makes sense. It's a shame that GLSL doesn't support overloading. Could implement that easily in the current.
It doesn't matter.
Of course it doesn't.
No, and what I would do is I'd have it as a thing that can be programmed here, and that would get passed down to the fragment shader, and it would be an extra operation that occurred in all cases. And most of the time it would be a 1. It would be a tiny bit of extra work for the GPU per fragment, which is probably not a big deal. If it is, then I can have a version with and without. It doesn't matter. I can have a whole bunch of different.
You're right. It could be probably I think static stuff is very little overhead.
Yeah.
Almost negligible.
So. Anyway, yeah. So, all right. Well, I guess.
It was really fun. Thank you so much for showing me all this stuff.
Thank you for joining me. I'll let you know when I have some more content, and if you're available and you feel like it, you can join me again. That'd be the greatest thing. So.
Yeah, that would be awesome. I want to see more code about game development, especially if you're a game dev. Like, watch this video all the way to the end. I know I'm saying it at the very end of the video, but I know that people sometimes go to the end of the videos to see some, some recaps.
Yeah.
So if you're hearing this,
well, I'm not a game developer. Like, I don't tell stories and things like that. I'm an engineer, so I can handle this really basic stuff when it comes to things like what kind of monsters should be in the game and what the game mechanics should be. And if you want to do like in Minecraft, how you get mud and clay and things like that, there's interesting creative game mechanics that I wouldn't think of, and I don't know how. For me, it's just, like, for me, the way I would want to do crafting would be like you pipe items into a crafting block, and depending on what the item types are, it'll combine them into different ways. You could implement like basic chemistry kind of things like that, right? Where it reminds me of something that Kerry KH did, where he had this online game sort of thing where people could say, all right, so a cloud is like air plus air, and rain is cloud plus cloud, and like they ended up with this massive tree of, if you combine this arbitrary thing with that arbitrary thing, it produces this new kind of thing. And that's all it was. It was just a tree of combining this with that gives you that. And it occurs to me that could be an interesting crafting system, where to craft, instead of having a 3x3 grid, it's you combine 2 items to get a third. You maybe combine that to get another thing. But so if you wanted to craft complicated things, you would actually create a pipeline and automate the crafting.
Yeah, that would potentially be like one way to do it, but that would be like a very abstract thing.
Yeah, it could suck.
Maybe chemistry. Yeah, chemistry concept. Yeah.
Yeah, it's just I would definitely have on my agenda things like auto crafting and movable entities that have state.
All kinds of movable blocks.
Blocks that have state could get moved.
Maybe potentially have like light sources of different colors, so you have to.
That is possible.
My god.
That would be possible.
And
colored light.
And then you could have also potentially like infinite world height.
Yeah, I don't want to deal with that. So one of the things I discovered is the way Minecraft does chunks. They have subchunks, but the chunks are vertical and they're world height. And I was doing it entirely in terms of subchunks. and in order to not lag the game, I was loading subchunks at a limited rate, like every so many, like every 100 milliseconds or so many milliseconds, it would load some more. And but the problem with that is that the vertical stuff would load in this weird way, and so I still have subchunk type chunks, but the chunk loader, I'm going to make sure that it does the full height at a time. And so because of that, if you have infinite world height and you don't want to be unloading chunks that are below you or above you, which can cause all kinds of problems, okay, then infinite world height wouldn't make much sense. It's just engineering. Yeah, there's a lot of things.
There's also game aspect issues that probably like light updates would propagate.
Oh yeah, that would be really expensive. Yeah. Well, here's one of the things that's going to happen is there are all these complaints that people have made about mulling in their engineering decisions, and like, why are they so slow to implement this, or why don't they implement this, and why don't they implement that? And I will discover firsthand why they don't do these things, because I'm going to discover just how difficult it is to do some of these things that people are asking for, and I will be able to tell you why that it was hard.
That's true.
That's one way to empathize with somebody, is to try to do their job, So
yeah. One day in the shoe of Mojang.
Yep.
Or in your case, it's probably been months or weeks.
What? What has?
Like developing their entire game engine from scratch.
Oh yeah, no, it's been longer than that. I mean, I have this whole C++ version that I have as a reference that took me quite a long time to develop. And so the only thing saving me time here is the fact that I'm able to copy a lot of what I did previously.
So it's like it's being ported slowly.
Yeah.
I see.
I mean, there's a lot of new stuff, and then there's a lot of porting. So, yeah, like the entity stuff. So far, I'm going to edit it again, but the entity stuff that I'm doing here is pretty much just a blind port of the C++ code, and then I will go and remove stuff that I didn't decide I don't want.
Review it.
Yeah, exactly. But because doing that thing where you could walk upstairs and like hop. And other things like jumping, those are things that took a lot of work to do, and to figure out and how to implement, and there's no way I want to like totally re-implement that from scratch. I'm going to port what I did, because that was a lot of work.
That makes sense.
Yeah.
By the way, will there be a third video? Like, when will we see like the follow-up?
Well, yeah. So like I say, I'll be doing some more work on this here and there. And when I feel like I've got enough content and you've got some free time, then we could do another video on more stuff that I add.
Yeah, that makes sense.
Yeah. All right, cool. Well, thank you so much. I'm going to go and stop neglecting my family now. I'll go ahead and upload this to YouTube. You have a, what time is it there?
It's for me. It's not late. It's 6:30.
Okay. Well, you have a good evening. I'm gonna go eat lunch.
The same. Say hi to your family.
I will. All right. And likewise. Take care. I'm gonna stop recording.